In this video, we are going to discuss some aspects of spin-spin coupling. Spin-spin coupling means peaks can be split due to neighboring or different hydrogens. Let us take an example here. This molecule having two different hydrogens. This is A type hydrogen and this one is B type hydrogen. If we stick this molecule to the NMR machine, then we get a peak like this. The rough sketch of the peak is like this. There are two peaks, one for A type hydrogen and the second peak for B type hydrogen. Now, if we look very closely to the B type B peak, then we will see, if we zoom up to 10 times, then we will see three different peaks. That means this peak B is split up to three peaks, and this splitting up to three peaks is known as triplet. Similarly, if you look at the A peak, and if you zoom it for 10 times, and you will see four different peaks. That means the A peak has split up to four different peaks, and these four different peaks are known as quartet. So this splitting, actually we are looking at the multiplicity of the peaks. These two peaks are split into different peaks, split up to different peaks. So actually we are looking at the multiplicity of the peaks. And this splitting of the peaks is happened due to the spin-spin coupling. Now, another term we should know is that these protons A and B are coupled protons. That means they are causing splitting of the peaks each other. So these two peaks are coupled protons. Now let us see how to predict the splitting would be observed. Let us see the splitted peaks in a mass spectra of splitted peaks of the same example. So this is our rough sketch of the spectrum, and this triplet quartet is due to the A type hydrogen, and this triplet is due to the B type hydrogen. Now there is an important rule for governing the splitting of the signals, that is called n+1 rule. Here n is the number of neighboring or different hydrogen. So let us see each and every peak A and B, how the splitting has happened. Let us take A proton, and what will be the value of n? This is the A type hydrogen, and this is bonded to this carbon, and this carbon is the neighboring carbon of that carbon, and these hydrogens are the neighboring hydrogens of A type hydrogen. So the number of A type the n value of A type hydrogen is 3, and if we put this into the n+1 equation, then we get 4 as n+1 value, and corresponding to the A hydrogen we will get four different peaks, and this 4 is correspond to these four different peaks. So this is the reason how we get four different peaks for the A type hydrogen. Similarly, if you look at the B type hydrogen, and what will be the value of n, and this is the B type hydrogen, and this is bonded to this carbon, and this carbon is neighboring carbon, and these two hydrogens are the neighboring hydrogens of B type proton, and value of n is 2. If we plug to the n+1 value equation, we get number of n+1 is 3, and this 3 is the reason for the splitting of the peak to a triplet. And this is how the splitting happened for this particular example. Therefore, by looking at the molecule, we can predict the number of signals and how the signals would split up. Similarly, another example, and in here we have two different protons. This is A type proton and this is B type proton. And if you see the n value of this A type hydrogen, and this is A type hydrogen, and this is bonded to this carbon, the neighboring carbon is this, and these B hydrogens are the neighboring hydrogens of A. So n value of n is 2. If we plug into the n+1, we get 3, and ultimately we get a triplet as the splitting. And similarly for B type hydrogen, what is the value of n? This is the B type hydrogen, and these two are the neighboring hydrogens of B. So we get the value of n as 2. Plug into the n+1 equation, we get 3, and ultimately we get a triplet again. And this is how the splitting happened to this particular molecule. Now let us see another example. This is the example, and let us assign the hydrogens. So this will be the A type hydrogen, and this will be again A, and this is again A. Due to the signal averaging, these three methyl groups are equivalent, and we will have all are equivalent protons. So these three methyl protons are A type, and that makes this proton is the B type proton. And if you see the n value of this A type proton, we can select any of these three, because any of the one you take, you get the same value for n. So we have to count the neighboring hydrogen, and let us take this proton, and these hydrogens are bonded to this carbon, which is bonded to this carbon, and this is the neighboring carbon, but there is no hydrogens bonded to this carbon. Therefore the value of n is 0. If you plug into the n plus 1 equation, we get 1, and finally we get a singlet as the splitting. Similarly, for B type proton, what will be the value of n? This is the B type proton, and this is bonded to this carbon, and that is bonded to this again this carbon, but there is no hydrogens bonded to this carbon. That is, there is no neighboring protons. Value of n is 0. If we plug into the n plus 1, we get 1, and we get a singlet peak as splitting. Similarly, if you take another example, we have here again we have A type proton, and this is B, and this again A, because this terminal methyl groups are equivalent. So we have this as again A type proton. We will see the value of n for this particular A type proton. This is the A type proton that is bonded to this carbon, that makes this carbon as the neighboring carbon, and these two are the neighboring protons. So the value of n is 2, and plug into the n plus 1 equation, we get 3, and we get a triplet as the splitting. Now consider the B type proton. Before that, if you take again this A type hydrogen, we get the same value, because this is bonded to this carbon, that makes this carbon as the neighboring carbon, and this are the neighboring protons. We get the same value. So if you take either of these A, you will get the same splitting. Now let us take the B type hydrogen. What is the value of n? This is B type hydrogen that is bonded to this carbon, and this carbon is again bonded to this carbon, which is having a 3 hydrogens. That makes the again this right side carbon also the neighboring one, that is also having a 3 hydrogen. So 3 plus 3, there will be 6 neighboring hydrogen for this B type proton, and plug into the n plus 1 equation, we get 7, and ultimately we get a multiplet as the splitting. Now let us take another example. Here also we have 3 different protons A, B, C. This is A, the middle one is B, and the right side hydrogen is C type hydrogen, because all of them are different. Now if we see the A type proton, what is the value of n? This is A type proton that is bonded to this carbon, and that is bonded to another carbon, that is neighboring carbon, that makes this B hydrogens are neighboring hydrogen. That means the value of n is 2. If we plug to the n plus 1 equation, we get 3, and ultimately we get triplet as the splitting. Now let us take the B type proton. What is the value of n? This is B type proton that is bonded to this carbon, that is again bonded to this carbon as well as this right side carbon. Both of them are having 2 hydrogens each. But remember, here these two neighbors are different. For B type hydrogen, the two neighbors are different. This is not equal. This is A and this is C. So in this case, we cannot consider the n plus 1 rule. Here the n plus 1 rule fails. We cannot apply the n plus 1 rule, because this B type hydrogen having two neighbors, they are different. In such cases, we cannot apply the n plus 1 rule, and we cannot predict what will be the splitting. We cannot count the number of peaks. So we consider the splitting will be a multiplet. Ultimately we get a multiplet. Now if you see the C type proton, it is what is the value of n? This is bonded to this carbon, that is again bonded to this carbon, that is the neighboring carbon, and these two are the neighboring protons, and we get the value of n as 2. We plug into the n plus 1 equation, we get 3, and ultimately we get a triplet as splitting. So here the important thing is, in case where we have two different neighbors, then we cannot apply n plus 1 rule. Now let us take another example, CH3. Here we have only one kind of proton, both are A. This is a symmetry molecule, so both are having A. If you see the value of N, uh, this is the A type proton, and this is bonded to this carbon, that is bonded to another carbon, and these are the three hydrogens. But remember, what n plus 1 rule says? N is the number of neighboring but different hydrogens. That must be different, neighbor and different, but here this is not different, these are same. So here also we don't have any neighboring hydrogen, and value of n is 0. If you plug into the n plus 1 rule, we get 1, and ultimately we get a singlet. Here the important thing is, a peak or signal cannot be split by its equivalent. It cannot split by equivalent. The neighboring proton must be different, so the equivalent signals cannot be split up. Thank you for watching.